Stop, the universe is thinking, and you're part of the thought. The detectors shouldn't care, but they do. We flip a switch after the photon's already flown, and the pattern on the screen changes like it heard us. Out in space, light that left a quasar billions of years ago still answers a choice we make tonight. If that sounds like magic, hold on, it's worse. Your late choice can be space-like separated and the counts still bend. Ancient starlight can set the dials and the pattern still follows. If matter feels even a whisper, we've been asking the wrong question. Is the universe a mind, and are we a thought inside it? 5 anomalies, 1 loophole, 40 seconds from now, the first glitch that refuses to die. The question we've been dodging. Here's the thing, panpsychism isn't a vibe. It's a bet about how matter works. Not that rocks have opinions, you know what, but that every physical thing carries a tiny interior, proto-experience, a minimal what it's like that isn't rich, isn't mindful, just a sliver of feel that comes with having cause-and-effect structure. That's the claim. Tiny, humble, testable, or it's worthless. So what would count as signal? Predictive leverage. Not poetry, not metaphors about the cosmos meditating. We need places where changing information conditions. What's knowable about a system, how it's embedded, nudges outcomes in ways energy alone can't explain. If a theory about feel can forecast non-random deviations when context flips, and those deviations replicate across labs and scales, then we're not in woo, we're in physics with new terms. Zero drop-off rule. Every 30 seconds we raise the stakes and bank a test. Before you flinch, remember the bruise that never heals in quantum theory. The measurement problem. Set up a particle to interfere with itself and you get waves on the screen. Add witch path information and the waves collapse to dots. That's old news, but the trouble keeps leaking out of the lab. We can delay the choice to gather path information until after the particle would have decided, and the statistics still shift. In cosmic versions, starlight born before Earth existed seeds the randomness for our settings, and entangled pairs still violate classical bounds. Whatever's going on isn't waiting for a human to look. It's about relations. What's recorded? What can be recorded? What's redundant in the environment? So the central question, said cleanly, do particles carry internal states that matter for how they relate, not just in position and momentum, but in informational terms? Do systems have an intrinsic side, a minimal integrated cause-effect power that behaves like a protofield? If yes, you get a universe where objectivity doesn't float free. It's built as information is copied and stabilized. You also get a path to tests. Change the copying conditions. Watch reality choose differently. The stakes are real. Ethics shifts if harm can ride on substrates beyond brains. AI alignment looks less like stuffing goals into black boxes and more like building systems that write transparent ledgers of their own world models, minimizing surprise without collapsing diversity. Free will gets reframed as constraint writing, our choices as local edits to the universe's ongoing computation. Cosmology, too. If the cosmic web carries not just mass and fields, but network-level memory, forecasts of star formation and lensing noise might need an extra term for information flow. Now guardrails. We're not saying electrons have rich minds. We're saying the minimal claim, if integrated information, call it 5, exists at any scale, even vanishingly small, then protofield tags along with causal structure. Tononi's integrated information theory in its 4th formulation lays out the axioms: intrinsicality, composition, information, integration, exclusion. A system feels to the extent it has irreducible cause, effect power over its own past and future states. That gives you a threshold to estimate, not a license to anthropomorphize. You might ask, so what about brain stuff leaking into physics? Stuart Hameroff and Roger Penrose updated Orch OR in 2014, arguing warm quantum vibrations in microtubules could sustain coherence long enough to matter for consciousness, with anesthetics disrupting tubulin resonance as a test. It's controversial, and evidence is mixed, but here's the useful piece. Tie conscious level changes to concrete, falsifiable physical signatures. That's the spirit we want. even if the microtubule story ends up wrong. Meanwhile, Vazza-Feletti quantum Darwinism comes in from a different angle and quietly hands us a tool. Decoherence doesn't just kill superpositions. The environment writes many copies of certain stable, pointer states. Redundancy explodes. Photons, phonons, dust, each carries offspring of the same fact. That's why many observers can agree without touching the system or each other. If the world keeps a ledger through redundant records, then facts are the entries that survive selection. Now ask, selection among what and by what criteria? If selection favors states that can be widely copied, you're already speaking about preference structures in matter. Not spooky minds, information with teeth. And you can watch it. Mutual information curves rise fast and plateau when small fragments already reveal almost all the classical info. Jerk's redundancy signature. And here, where a panpsychism loophole peeks through. The observer that matters might be any physical process that integrates and propagates information, not a human. Treat proto-experience as the hidden variable that isn't hidden. It's the system's intrinsic cause-effect profile. If that's right, then changing information relations, what's available to be copied, delayed, masked, or made redundant, should sometimes tilt outcomes. Not always, not everywhere, but in edge cases we can design. We need falsifiable bets. Blind delayed choice runs with cosmic randomizers across labs. Materials with engineered hysteresis that respond to informational inputs without energetic changes. Astronomical surveys where filament network metrics predict small biases in lensing residuals. Safety valves built in. If the signals vanish when context is masked, the idea fails. That's the standard. Why push this now? Because the anomalies piled up, and because our tools caught up. We can count redundancy directly in experiments. We can measure tiny integrated structures in photonic circuits and logic gates. We can map the cosmic web like a nervous system and compare connectivity spectra to the cerebellum. And in the 2020s, researchers like Franco Vazza and Alberto-Feletti lined up specific echoes. The cortical and cerebellar network shows on the order of tens of billions of neurons, about 69 billion cerebellar granule neurons, while the observable universe holds on the order of 100 billion galaxies. The brain's tissue is roughly 77% water by weight, while the cosmic energy budget is roughly 73% dark energy. And the fluctuation spectra and clustering measures in both systems rhyme over orders of magnitude. Different stuff, similar bookkeeping, structure and spectra, not one-to-one parts. Get this, none of that proves the universe thinks, but it forces a better question. If physical law cares about information, its storage, flow, and erasure, then maybe mind isn't an add-on. Maybe it's what certain informational geometries feel like from the inside. Okay, the lab trick that started the fight. The double-slit that wouldn't behave. So picture the room. Lasers low, air still, a single photon source ticking like a metronome. We aim those photons at a wall with two narrow slits, then a screen behind it. No tricks. When both slits are open and nobody learns which path the photon took, you get an interference pattern, bright and dark fringes like ripples crossing on a pond. That's the textbook wonder. Each photon lands as a dot, but the dots, over time, sketch waves. It's as if a single particle went through both, then interfered with itself. Now we nudge the setup. We put tiny detectors at the slits that can, in principle, tell us which one the photon used. We don't have to glare at the data. It's enough that the which path info could exist. And bam, the fringes vanish. The dots cluster into two humps, the pattern you'd expect if pellets shot through one hole or the other. Same energy, same photon source, same everything except the information conditions. The world flips behavior because aboutness changed. Here's where it gets touchy. People used to say it takes a mind to collapse a wave, but run the experiment without humans watching live. Let the detector write to memory, seal the drive, throw it in a safe. The pattern still collapses. If you scramble the record so completely that even in principle nobody could recover which path info, the fringes creep back. The system responds to whether which path facts can become part of the environment's record, the world's redundancy ledger, not to eyeballs. That's the key pressure point. Then John Wheeler pushed it harder with the delayed choice twist. You let the photon pass the slits first, then decide, after it should have picked, whether to preserve which path info or erase it. The statistics still obey your late choice. It isn't that the particle time travels to fix its path. It's that quantum outcomes care about the whole arrangement, including the final availability of path information. The choice can be space-like separated, causally clean, and the math doesn't blink. Wheeler didn't stop at benchtops. He imagined the cosmos as interferometer. Light from a distant quasar curves around a massive galaxy, two paths to a split by gravity's lens. Billions of years en route. If we set our detectors so that path information could, in principle, be known, distinguishing which side the photon took, the arrivals act like particles. If we instead combine the paths so that the which-way clue is erased, we recover interference-like correlations. Our present hardware, pointed at ancient light, changes what pattern we see. That's not magic. That's the universe telling us it plays by relational bookkeeping. But wait, here's where it gets interesting. In some lab runs, we make the which path decision using a randomizer that's outside the experiment's past light cone at emission, say, a cosmic source of randomness from starlight far away. It helps slam shut conspiracies about hidden coordination. You flip detectors on or off based on photons born before the Earth formed, and still the pattern follows the information setting. Whatever is steering outcomes isn't local guesswork or human wishful thinking. So what's actually happening step by step? When the environment can carry redundant records, pointer state offspring to borrow Jurk's phrase, about which slit the photon used, those records proliferate. Scattered photons, thermal vibrations, all the little witnesses pick a basis and copy it. That process, decoherence, bleeds phase information into the world. The interference needs phase coherence. Lose it to copying, the fringes fade. Keep the which path uncopyable. Mask it, scramble it. Coherence survives enough to draw the waves back in the count. Stakes, not just spectacle. If mere possibility of recording changes outcomes, then measurement means becoming a fact in the environment. That's a selection rule. Facts that can spread. Facts that can't, don't. And the system's behavior bends around that. You don't need a ghost in the machine. You need a criterion for what gets copied. Here's a clean micro story. A grad student runs the apparatus at 2 in the morning. Same photon rate, same alignment. The only switch that flips is a logic gate routing the detector outputs into a hardware shredder that thermalizes bits on write. After 3 hours, they stack the hits. The interference visibility nudged up, just enough to tease, not enough to claim victory. Next week, they rerun with the shredder disabled. The visibility drops back. They send the plots to their advisor with 3 words: please check me. This is where the field lives, in hairline shifts tied to information paths. Now is this choice, careful. The photon isn't self-conscious, but the system doesn't act like dead pellets either. It responds to context, whether the world will hold on to a particular relational detail. That's a thin kind of preference. Call it the world's bias toward states that can be redundantly real. One more turn of the screw. Delayed choice quantum eraser variants. Entangled pairs are born. One heads to the slits, the other to a separate detector array that either preserves or erases which path correlations. If you later sort the first screen's hits by how the partner was measured, fringes and non-fringes sort themselves out in hindsight. No signaling, no paradox, but a clear message. Interference is a global property of correlations, not a local, per photon quirk. This is the moment everything changes in our story arc. The double-slit isn't a party trick. It's a stress test for whether physical law cares about information relations. And it keeps failing the "it's just energy" story in the same way. Outcomes track what can be known, copied, and kept. That's the glitch that won't add up if matter is only mute stuff. Cosmic bell tests and the freedom problem. While that was happening in the slit room, another fault line was opening, far from screens and fringes. Bell's idea came in like a quiet bomb. If the world is local and realistic, things have properties and influences don't outrun light, then certain correlations between distant particles can't climb past a hard ceiling. That ceiling is a Bell inequality. Violated and something's got to give. Locality, realism, or the way we think about choice. So here's the setup. Create a pair of particles in a joint state, spins or polarizations linked by a common birth. Fire them to distant detectors. At each station, an experimenter picks a measurement setting. Call them angles A or A here, B or B there, and records up or down, left or right. Do this many times. If hidden variables tucked into the particles pre-program their answers, you get correlations, sure, but never strong enough to cross Bell's bound. Quantum theory says, yes, they cross, and in lab after lab they do. Now remember, this is the 1970s through the 1990s at first, optics on carts, tangled fibers, skeptics with clipboards. People worry about loopholes. Maybe a trick light path lets the detectors talk. Maybe the particles carry a cheat sheet key to the settings. Maybe the random choices at the ends aren't free enough, contaminated by some common cause. Close one door, someone points to another. It took decades to pin them all. Here's where it gets interesting. To kill the freedom of choice complaint, the idea that your setting choices are secretly correlated with the particles' hidden plans, teams turned the sky into a dice cup. Cosmic Bell tests used ancient starlight as randomizers. Instead of letting a computer pick A or A, they split incoming photons from stars or quasars into color bands, mapping red to A, blue to A, and the same trick on the other side. Those stellar photons started their trip hundreds of years ago, sometimes billions. If any conspiracy coordinated the settings with the particles, it would have to reach absurdly far back, weaving through half the observable universe. They ran it. The entangled pair still blew past the classical bounds, and they locked down timing so the setting choices and the partner detections were space-like separated. No causal whisper could sneak between them at light speed. The numbers didn't flinch. Correlations rose to the quantum limits, Searlson's bound exactly where the math predicts. Not more, not less. That precision is its own message. We're not bungling into spooky anomalies, we're mapping a rule. Stakes right now. If local realism breaks, you have options, but none are cozy. You can drop locality, allow influences that aren't signals but stitch the outcomes together outside spacetime. You can drop realism, say properties don't exist until measured, full stop. Or you can keep both and swallow superdeterminism. Everything, including your setting choices, is locked from the start. Freedom becomes a story we tell after the fact. Most physicists hate that last move. It saves the appearances by flattening agency into wallpaper. Meanwhile, something else was happening in the analysis. The symmetry of these violations isn't wild, it's tuned. You never see correlations that would let you send messages faster than light. You always see just enough to rule out local hidden variables. That balance looks like law, not accident. It also smells like relational structure doing the work. The outcomes aren't set at a mission, and they aren't handed in at arrival. They're born out of the joint context of both measurements. Unknown to them across town, a grad student stared at a star catalog pinned above her bench. She traced the light cones by hand, when each photon left its source, when each detector clicked. She circled a span of hundreds of millions of years where any plot to sync settings and particles would have to act. Then she wrote in the margin, "If not freedom, then what is choice here?" That question keeps echoing. So where do choices live in a universe like this? Here's one clean read. There aren't agents at the particle level, but there are constraints. The joint measurement context, two settings, two detectors, a shared origin, defines a space of allowed correlations. The world chooses within that space according to a rule that respects no signaling and the quantum bound. It isn't a coin flip, and it isn't prescripted by local variables. It's a kind of global fit, outcomes that satisfy all the constraints at once. This is the moment everything changes for our thread. Cosmic Bell tests cut out human bias and still leave us with correlations that care about relations, not parts. They narrow the freedom of choice loophole to the edge of absurdity. They suggest that if there's order underneath, it isn't a list of hidden instructions in each particle. It's a web-level constraint, a ledger that tracks what can cohere given the entire setup. Wait, the problem gets louder outside the lab. When you seed your randomness with light older than civilization and nothing budges, you've dragged the question into the fabric of the sky. If correlations are law, not conspiracy, then choice isn't a human privilege. It's how physical contexts resolve uncertainty. And if that's true, the door cracks open for our loophole. Intrinsic structures, protofeel if you like, aren't deciding like little minds, but they're participating. They make relations matter. Get this, the cleanest part is also the hardest to swallow. Bell doesn't prove minds in matter. It proves dead matter with local dials can't explain the data. The replacement looks like a universe that computes constraints across distance, then outputs consistent, biased pairs. Not signals, not scripts, fits. And once you're thinking that way, you're ready for a weirder claim. Particles also act like they remember. Quantum Darwinism and objective facts. 3 days earlier, something strange occurred in a quiet lab with a single ion trapped in light. The team wasn't trying to see a cat both alive and dead. They were auditing the world's bookkeeping. They let the ion interact with a tiny environment. A few qubits standing in for the air, the room, the rest of reality, and asked a blunt question. When exactly does a fact become something many observers can agree on? Here's the move. Start with decoherence, the part everyone nods at. A system in sewer position taps the environment and phase leaks out, but Jerk pushed past that. He argued the environment doesn't just blur quantum states, it copies certain stable ones over and over. Those are pointer states. And the copies, think of them as information offspring. Photons, phonons, dust grains, little witnesses, carry many redundant imprints of the same simple facts. Position here, orientation there. Objectivity in this story is redundancy. If a fact is written into enough fragments of the environment, separate observers can sample different fragments and still agree. That redundancy, R, shows up as a fast rise and early saturation in mutual information between the system and small environment fractions, a measurable plateau. Stakes right here. If objectivity comes from redundancy, then reality is what's under the hood. It's what's been broadcast so widely it can't be missed. That changes what we test. Not is the wave collapsed, but how many copies exist and who can read them. Action step by step. In model universes, one small system, many environments, Jerk and collaborators showed that random states don't store info redundantly. You get scraps here, scraps there, no consensus. But in the kind of branching states decoherence naturally produces, redundancy scales with environment size. One bit about a pointer state can be copied into thousands, millions, effectively for free. That's why you and I both see the chair at the same place without touching it. The photon halo around it already told us, 100 billion times, chair here. Then came a wave of proposals and tabletop demos. People measured mutual information between a system and growing fractions of its environment. The telltale curve rises fast. Tiny fragments already give you almost all the classical info about the pointer state, then saturates. That plateau is the signature of redundancy. Recently, superconducting circuits even built controlled branching. The system's state radiated out into multiple channels, and the information plateaued exactly as quantum Darwinism predicts. It's not philosophy, it's a pattern you can draw. Impact. Once you can count redundancy R, you can define objectivity operationally. Multiple observers, no coordination, same answer. And you can hunt for pointer states by the trail of their offspring. That's a new kind of physics knob. Tune the environment's ability to copy, watch facts harden or melt. Meanwhile, something else was happening in the interpretation. If selection favors states that can be widely copied, that looks like a preference baked into matter. Not a mind making choices, but a rule with teeth. Survive the broadcast or vanish from the record. It's a thin step from there to a proto-experiential angle. Preference structures are about what matters to a process. If a system has an intrinsic cause, effect shape, its own way of pushing and being pushed, then the environment's copying can be read as feedback on that shape. The feel is minimal, but the selection is real. Here's where it gets interesting for tests. If the world writes a ledger, we can jam the pen. Engineers already isolate environment fragments, scattered photons, specific vibrational modes, and read them like independent children of the same fact. Change how many children survive. Mask a subset. Force a mismatch between fragments. If objectivity collapses when redundancy drops below a threshold, that's a clean, falsifiable lever. Conversely, boost redundancy on a non-pointer basis, and see if the world resists. Decoherence should shove you back to the natural basis, like a current snapping you into the channel. Microstory. A postdoc in Zurich rigs a crystal so its scattered light splits into 8 fiber channels. Each channel hits a detector array on a different bench. 4 colleagues, no crosstalk, each logs the state read from their photons. When they compare later, 7 agree, 1 doesn't. They trace it to a beam drift that reduced redundancy on that channel below the knee of the curve. Fix the alignment, run again. 8 out of 8 align. The room feels weirdly calmer. It's not mysticism. It's the hum of a ledger writing cleanly. Now remember, this is the 2000s to the 2020s and the math matured. Mutual information splits into classical and quantum parts. Quantum discord tags the residue you can't access redundantly. Environment as witness becomes a slogan and then an experiment. And a sharper picture forms. The world looks classical where redundancy is huge. It looks quantum where redundancy can't grow. That's your map. Impact, larger frame. Quantum Darwinism answers why we agree, not why outcomes happen. But paired with our Bell and double-slit pressure, it adds steel. Measurement is environment-mediated selection for copyable facts. The loophole we're chasing slots in neatly. If protofield is just the intrinsic side of cause, effect, power, then facts are the footprints of how systems couple and what the environment prefers to proliferate. You don't need human eyes. You need copying conditions. So if the world writes, can it also learn? Hysteresis in matter, glassy aging time crystals, those look like memory. If memory is everywhere, redundancy is the ink and selection is the grammar. Which means the next question isn't abstract. It's practical. How does matter remember being pushed, and when does that memory push back? Memory in matter, hysteresis, glass and time crystals.